Hey folks, welcome back to another lesson, and we're now going to look at irradiance and worked example. So we're going to look at how to apply the irradiance equation to carry out calculations. So just a wee reminder, remember irradiance is the power over the area, and these are the units. And remember how lasers have a higher radiance than a bulb, and this is why they are more dangerous than a bulb. We also then looked at this equation, I1 d1 squared is equal to I2 d2 squared. Check your relationship sheet. I don't think they give it to you in this form. I think they give it to you as I times d squared is equal to a constant. So just be familiar with this equation because this is the one we're going to be using quite a lot. So let's just get straight into an example. As always, if you feel confident, try this yourself. Otherwise, I'll take you through the solution. So a pupil measures the irradiance of a 100-watt bulb as 0.2 watts per meter squared at a distance of 2 meters. Calculate the irradiance measured at a distance of 4 meters from the bulb. So pretty straightforward, do our KFC technique. So we know that I1, D1 are these quantities, and we're looking for I2 given that D2 is 4 meters. So then all we do is write our equation down, plug in the numbers, and then rearrange it to give us I2 as 0.2 watts per meter squared. Pretty straightforward, nothing particularly tricky there. Okay, so let's look at an example of a past paper question. So notice this is the same setup as we had in the previous lesson, and it says, describe how this apparatus could be used to verify the inverse square law for a point source of light. So pause the video and have a go of it yourself, and then we'll talk through the answers. Okay, hopefully you wrote your answers down and you have something similar to this. Okay, obtain values of radiance for different distances, plot a graph of 1 against I against 1 over d squared, and then the graph of I against d squared, 1 over d squared, is a straight line through the origin. This verifies the inverse square law of light. So if you are struggling to write this down, make sure you copy this and you can use this as a model answer. And then finally, you might be wondering, why bother study this? Well, this irradiance relationship is really important because we can use this to determine the distances of stars by using our own star as a reference compared to the brightness of the distant star. So what I mean by that is, if we know the brightness of our own star, and then we can measure the brightness of another star, then we know the distance of the Earth to our own star. So we have I1 D1. And if we know the brightness of the other star, we've got I2, we can then work out D2, which is how far the star is from our own Earth. So you can see how something which is not obviously related can be used in lots of different situations. And that's what I really like about the physics in this case here, is that we've gone from talking about the brightnesses of light bulbs to the brightnesses of suns.